My name's Tammy Butow. I was part of the panel yesterday as well. I'm a principal SRE at Gremlin. You can find me on Twitter at Tammy Butow. Previously I worked at Dropbox as the SRE manager for databases and also storage, so block storage. And I was there for the big migration off S3 into our own Magic Pocket storage system, which we built ourselves. And then before that, I was at DigitalOcean, which has many data centers across the world and is a cloud infrastructure company. And then before that, National Australia Bank, where I worked across mortgage broking, foreign exchange, internet banking, so many different systems. And that was a really good experience too. And I've actually been doing chaos engineering since 2009 because I started doing it when I was at the National Australia Bank. There we call it disaster recovery, which is one of the things that you can do for chaos engineering. So if you're wondering if it's similar, yes, it totally is. And a lot of the time I've found folks in finance actually have done a lot of chaos engineering because you have to be able to meet the regulators' demands and to be able to continue to operate and have everyone be employed. There's a lot of rules and regulations in those industries. And I decided it would be cool to take all that knowledge from working in finance for 6 years in technology and then go and work at startups. And it's been really interesting and a great experience. So today I just wanted to talk to you about this big problem that we have, which is that every system is becoming a distributed system. So who here, put your hands up if you use cloud infrastructure at all? Yeah, lots of people, right? So, there we go. A lot of the time, if you're using cloud infrastructure, you're probably using multiple different services, trying to weave them together to create a system for yourself, for your company. A lot of the time, you might use some Lambda, some EC2, some Kafka, some database. All these different things have to work together. And then also the network needs to work for everything right as well. So today I wanted to focus a lot on network chaos engineering. It's something that we often don't talk about. It's relatively new, but it is possible. And I thought it was also really relevant. On the panel yesterday, we talked about that too, how being an SRE means you get to learn a lot more about network engineering. So true for me. I've learned so much more and it's made me a better engineer. But the problem is systems are really complex. These are some diagrams that show all the microservices and dependencies from several years ago for Amazon and also Netflix. So if you see here, how is a human supposed to understand all of these dependencies and the dependency mapping between each of the different services? Very, very tough. I mean, a lot of these companies, even if you have thousands of engineers, tens of thousands, hundreds of engineers, it's not really possible to understand how everything works and how everything can break. So it becomes really tough these days. Very different to back in the early 2000s where maybe you had a monolith system and everything was on maybe even one machine and it went down and you brought it back up. So these days there's just all these different systems and different components that need to work together. So that's where I think chaos engineering can really come in and help you out. So what is chaos engineering? Thoughtful, planned experiments designed to reveal weaknesses in our systems. Who here has done some chaos engineering before? Put your hands up if you've done any. Ooh, God, yeah, got some hands. That's awesome. I gave a lot of talks last year, about 30 talks in 5 months, because I just wanted to help people learn about this concept. And when I said who's done chaos engineering, no hands went up at all, usually ever. So yeah, pretty interesting. Who here has heard of Chaos Monkey? Usually get a lot of hands for that one. And Chaos Monkey is a tool that allows you to actually just do shutdown of instances on AWS, and it's open source and on GitHub. But it is just that one attack, that one type of chaos engineering. So today I wanted to really take a step back and talk to you about all sorts of different types of chaos engineering that you can do. But really the idea is that you want to inject something harmful to build an immunity. So we talk about it a lot like a flu injection. That sort of idea. That makes sense to a lot of people. If you say, why would you want to inject something bad? Seems, is that dangerous? Is it okay to do that? I myself, I had to do chaos engineering because they were well, we're going to fail over from this data center to the other data center. It better work. Otherwise, it's going to get written up and given to the regulators. So you just had to do it. That's kind of the place that I came from. And the thing is, I understood that because I thought, well, if we don't test that failover works, how can we ever really know if it works? And obviously, every single time that we did our disaster recovery failover tests, something broke and was unexpected. And then we would have to redo it, fix whatever was wrong, and then redo it and pass. So you really needed to make sure you were passing. And I never went into that test and failed twice for the same thing. Never. That would be bad. That's how I was still there for 6 years. But yeah, it's interesting. It's high pressure because you feel like in that sort of environment, everybody's job in every single team, from the bank tellers to people, mortgage brokers, they really rely on you to make sure that the systems are functioning and correct so you can keep your license. So to me, it totally makes sense to make sure that you can actually verify and test and prove that your systems do work if something occurs and something goes wrong by injecting that harm. So test proactively instead of waiting for an outage, waiting for something to happen. The other important thing is to define the blast radius. So this is really important. Start with something small. Do a small experiment first. Gradually learn more and more about your system and increase the blast radius. Do bigger impact chaos engineering experiments, and then you're going to learn as you go. I never want anyone here to go in tomorrow and be like, let's fail over the data center without any preparation or, taking some steps to get there. So that's very important. So what is the value of chaos engineering? I myself have had so much value from doing chaos engineering. I was able to actually get a 10x reduction in incidents in 3 months working at Dropbox for my first 3 months for the database systems. So that's from like many, many incidents a week down to only a few. 10x reduction, pretty awesome. I was going for a 20% reduction, was very happy. And then also after that, I got a 100% reduction in SEV zeros, so major catastrophic outages for 12 months following that first 3 months. And the main way that I think is important, you need to do chaos engineering experiments. That's how I did it. So I love to share that. The other thing is focus on MTTD, which is mean time to detection. I wrote a book about it for O'Reilly because I really believe that it's important. If you don't focus on MTDD, then you don't really know what's happening in terms of what's occurring for the customer. What is the customer impact? Because that is from the time that something is broken or not working to the time that you as a company know. That could be hours, weeks. I've even seen it be years. 3 years is the worst one I've seen. So you need to really measure that amount of time. The other thing you can do is do on-call training. So this is where you do fire drills. And you're preparing yourself to be able to understand how do you all function if something goes wrong, if there's an incident that occurs and you're on call. So who here, put your hand up if you've ever been told, hey, you're on call, here's the pager, good luck. Yeah, same. So that's not very good training for on-call. Also, it's not good for your customers. It's not good for your business. If you're trying to create a really great customer experience and stay running for a long time and, be a profitable company that runs for many years with happy employees, happy customers, I think on-call training is a really important thing that you can do. And I actually was the first person in the world to come up with this idea. I was just like, why don't we do training? Like we could use chaos engineering to just inject failure. We can just like reproduce common outages that have happened in the past using chaos engineering experiments, sit in a room together and just run through those incidents and be like, this is what you should do if this incident occurs. Like if DNS doesn't work, which, who here has ever worked on a DNS outage? Yeah, like lots of people, it's very common. So what you can do there is you can inject the failure and make sure that your team knows what to do, what steps they need to take, who they need to communicate with across the company. So not only the technical side of the incident, but also the people side, very important. And that helps you improve your mean time to detection as well. Everyone's trained up, they know what to do. So another great way to use chaos engineering. It's also very possible to measure the cost of downtime. A lot of companies don't do this, but we came up with this calculation. Cost equals revenue lost plus employee productivity plus customer chargebacks, SLA breaches, plus brand defamation and employee attrition. So Amazon's estimated to lose $220,000 a minute, and the average e-commerce site loses $6,800 a minute. So that's a lot of money being lost due to outages and downtime. And, you really have to think about the customer there. When I was working in banking, I had this mentor and I was working on mortgage broking first. He always said to me, whenever there's an incident, think about that person sitting outside their dream home with their truck filled with all of their stuff and they can't get into their house because you broke the system. And I was like, oh, alrighty. I was like, but it's true. Like we don't often think how does what we do impact the customer? But yeah, what if you've been shopping around for 3 years for your dream home, you finally found it, and then the mortgage broking system doesn't go through and somebody else ends up getting that deal? and gets that home that you really wanted. Like there really is a big impact to people's lives with what we do day to day. So I think that's really important to always remember. So now let's talk about network chaos. So I was doing a lot of research before I created this talk, and I couldn't find anything really where people were talking about injecting network chaos. So packet loss, latency, black holing, traffic, that sort of thing. I was trying to, see what are people doing out there. And also when I was working at Dropbox, we actually had quite a few network related incidents. But, there was no way that I could think of how can I really make sure that this incident doesn't happen again, which I think is a good thing that you can do with chaos engineering. And example of an outage that I worked on was I was leading the databases team. We were sending, backups, clones, restores. We were processing those every single day. We were measuring the amount of time that it takes to process a backup and a clone and a restore. And suddenly they got really slow. So we were like, what's going on? Not really sure what's happening. They were fine last week and now they're really slow. And we had to do a lot of investigation to identify what was wrong. Anyone want to have a guess at what might have been happening? Yeah. It could be so many things, right? Deploys, some sort of change. It was actually because the network engineering team had implemented QoS, so quality of service, and they were throttling our traffic. So yeah, that's a common thing that, network teams might do. They'll say, okay, we want to be able to prioritize different types of traffic and give, certain people, certain teams the ability to be able to, have a faster ability to do whatever they're doing. And for us, for database backups, clones, restores, those were slowed down, which is not good because what happens if you have a major outage and suddenly, you can't restore from a backup, then it means that maybe it takes you not a few hours to restore, or, if they're big databases, it might take you days to restore potentially. So it was very good that we identified that problem. I was like, okay, cool. We identified the problem, we fixed it, but how do we make sure it doesn't happen again? How can I do that as a service owner? That's something I think is really important to think about. So one of the things I did find though was this article which talked a lot about the impact of packet loss, the impact of latency on voice over IP. So I was like, okay, there's one article that talks a little bit about it specifically for VoIP, but I know for myself of incidents I've worked on, it impacts every system really when there's networking issues. I know at DigitalOcean, I became really good friends with the network engineering team because I had to, because I was able to then resolve my incidents faster. Who here has worked on an incident related to networking? Yeah, everybody. There you go. It's interesting there's not much written on it. So, what can we do in terms of network chaos engineering? So when I joined, I was interviewing, I was deciding where to go next, and I interviewed with Gremlin, and I decided I would try the product first before joining the company. Just wanted to see what it was like. And I saw there that you could do network chaos engineering experiments. I was like, wow, this is so cool. You could inject packet loss, you could inject latency, you could do black hole traffic, you could do DNS failover. So then it started to make me think how could I use this to prevent incidents related to networking? And also it enables you to just explore and understand how your system operates when there are networking issues. And I'm going to walk you through some demos and I'll show you how, even for me, when I was doing these experiments, I was setting them up. I often got different results than what I expected, which is one of the really interesting things that you'll find with chaos engineering. You'll have a hypothesis, but often you'll be really surprised with the results. So first off, we're going to look at latency injection, then we're going to do packet loss, and then we'll do black holing. So the example demo microservice application that we're going to talk about today is called the Hipster Shop. This is actually a demo app from Google. You can see here some interesting things to point out. It's good for us when we go into all these experiments, is that there is a cart service. So shopping cart, it's an e-commerce store that has just a cache, which is Redis. So you can see there's not so much in terms of database, high availability or anything like that for there. There's also a recommendation service. There's a product catalog. There's a front end. There is a checkout service, ad service, email, payment service, shipping service, and a currency service. So those are all good things to know about before we go into doing these experiments. You can actually also open it up right now if you want to take a look at it and just try it out. If you go to this IP address, 35.238.163.103, and you can just have a look at what does that look like when I navigate around. With this hipster shop, what you can do is you can add items to your cart, you can make purchases, you can place orders, you can add more items, and you can navigate around the store. So a pretty simple like e-commerce store. Does anyone here work on an e-commerce store? Few people. Awesome. That's great. Anyone want to yell out where you work at or? Dell. There you go. Dell.com. Boom. Any others? Awesome. Financial too. Okay, cool. That's great. Okay, so let's dive in. So the first one I wanted to talk about is latency injection. So when you're doing your experiments, our customer experience team created these chaos experiment cards. And we think a good thing to do is to sit down and say, okay, what is the application that I want to do an experiment on today? Ours is the hipster shop. So we can pretend that today we all work at the hipster shop. What monitoring tool are we going to use to validate our experiments? That's also super important. Validate your experiments using monitoring. And also often I would say alerting too if you use something like PagerDuty, VictorOps, something like that. Then what is the attack? It's a latency attack. Impact of the failure, we're going to attack the payments container. We're just going to impact one container. This demo application is running on EKS, AWS, so it's a Kubernetes demo application, and you can run it yourself. It's on GitHub as well, and we're going to inject, 200 milliseconds. It's also important to think what might the abort condition be. So if you need to stop the attack, you want to be able to say, okay, we're getting 500s, 400s. We need to stop the experiment right now. We call chaos engineering experiments attacks at Gremlin, so I kind of use those terms interchangeably. So the next thing is, what is our hypothesis? So my hypothesis for this would be, if I inject latency into the payments container, then I expect when I place orders, it's going to be a little bit slower. It's only 200 milliseconds because I'm starting off with a smaller blast radius. So that's what I expect to see. So let's try it out. So I'll show you how it works. So first off, we go to new attacks and we click on containers, and then we need to find that payment service. So we can just select it. And we're going to go to network, latency, and then inject 200 milliseconds. Okay. And then we click unleash. And then it's going to start running our experiment, our chaos engineering attack or experiment. So from here, it takes a little bit of time to set everything up, but it's going to actually inject latency for that one container. So then I'm going to show you what the actual application looks like as well. So this is what the hipster shop looks like. This is me adding items to my cart, clicking place order, browsing other products. And usually it's actually a lot faster. That was actually quite slow. So I click add order, place your order. It's a bit slow. Usually it's quite fast, but I would only know that because I've been using this demo application quite a lot. I previously run it on AWS EKS. And I think an interesting thing to think about here is, how often do you look at your UI when you're working on incidents and learning about how your system works? I know for myself, and this is where we can also look in Datadog. I've got everything loaded up into there. And we would want to think too, how does this show up in my monitoring? Am I able to identify it? Does it show up in any other reports? Like if it was a database experiment, does it show me that things are running slower now? So yeah, that's that there. But one of the interesting things that I learned that made me think about looking at the UI during chaos engineering experiments was because I was the incident manager on call for the S3 outage when US East 1 failed. Anyone else impacted by that outage? A few people. It was a big one, right? And one of the interesting things is we knew that something was broken because we were getting a lot of customer tickets, but we didn't understand what was not working because the customers weren't very clear. They were just like, Dropbox isn't working. I'm like, well, what part of Dropbox isn't working? I don't understand. And on the back end, our monitoring and alerting wasn't really telling us because we thought we'd moved completely off S3. But then someone said to me, hey, Tam, just go look at the UI. And I was like, all right. So I opened up the UI. I was looking around. Oh, like image thumbnails, none of them were working. So thumbnail processing wasn't working, which meant that if you open up Dropbox, everything was just like a big X for every single image. So that was what happened. But there's, sometimes it's just not possible to really know like how your system doesn't work unless you look at the UI. So I'm actually a big fan of that. And then that made me think even more so like, how can I push this even further? What if I talk to the UI engineers, learn more about different failure modes, and then talk to them about how we can fix those different failure modes? Like, can I get my images from a different, different storage service? And if there's an issue, can I fail over and grab the images from there? They're like, yeah, totally. Of course we can do that. So there's a lot of cool stuff you can do when you explore more. So now let's look at packet loss. And first off, was that kind of like what everybody thought you were going to see? Like a little bit slower, nothing too massive. Now we're going to do some more extreme ones. So packet loss. Alrighty. So what I'm going to do here is there is a Kubernetes dashboard that you can use. It comes out of the box with Kubernetes. It enables you to see your Kubernetes infrastructure, what you've got running. It gives you more data on Kubernetes. The monitoring tool is Datadog. Hypothesis will have slower responses, but ultimately success. And maybe we'll abort if there's a rise in errors. We're going to do a 70% packet loss, which is very high, but we're increasing the blast radius. And we're going to run it for like a bit of time, not too long. Okay, so has anyone seen the Kubernetes dashboard before? Okay, a few people, cool. Yeah, you can get it. Yeah, I think it's pretty handy. I really like it. So let's have a look. So this is the Kubernetes dashboard up the top. And then you can see here what I'm doing is I'm going to run an attack in the bottom on the dashboard specifically. So I search for Kubernetes dashboard. And I'm going to click network. And then I'm going to click packet loss. I'm going to change it to 70%. And now I'm going to run the attack. And so I expect maybe it'll be a bit slower, but it should ultimately succeed when it starts to run the attack. So it takes a little bit of time for it to start running. Anyone else expect anything different to happen? Nope. Okay, so it looks like things aren't loading. Alrighty, so I don't have any more images, but I also have this. Proxy error, context cancelled. Showing up in the logs. All right, that's interesting. Getting some log messages because of just doing a packet loss attack. Trying to load anything now and nothing's working at all. It's just like super slow, which is much more than I thought it would be. And also some interesting things are not working, like some text is missing from the top in the menu bar, the blue bar. So that's weird. Like, why is the text not loading, but other pieces are loading? It's not very heavy to load a piece of text, but the menu's loading on the left. Still getting a few more errors while this attack's running. So this is interesting too. It shows you like when there is packet loss, what type of failure occurs, like what is your graceful degradation path. So now cluster arrow nodes is showing up again, and the images are showing up again too because the experiment has finished running. So it's actually finished now. So that to me was really interesting. Why? I actually ran this same experiment on EKS and AKS, so Azure's service, and it was different. So the dashboard actually had different results. On AKS, cluster arrow nodes totally shows up fine. So I was like, oh, that's really interesting. So out of the box, like it just makes you think, whenever you're trying out a new piece of software, if like anyone built it, Amazon, Microsoft, it's really good to actually run your chaos engineering experiments before you start using it. Like say if you're thinking maybe I want to use Lambda, or maybe I want to use, a new service that Amazon just created or Microsoft just created or Google created, you can actually pit them up against each other and see which one is more reliable, which one is more durable by doing chaos engineering experiments. Specifically, like I think networking ones are interesting because we know we're always going to have networking issues. Alrighty, next one is the black hole attack. Okay, so here what we're going to do is a black hole attack for payments. Just one container, 120 seconds. So let's have a look at that. Anyone want to guess what's going to happen when we black hole traffic for the payment container? nothing's going to work. Nothing just for payments or? Interesting. Maybe. Okay, so yeah, here we are. We're trying to set up the attack. So we don't have to change very much. I'm just going to run it for a little bit longer. But I click back black hole. I selected the payments container. Now I'm going to unleash the experiment. I've learned so much myself from running experiments about how systems can fail in unique and interesting and different ways that you don't expect. This one probably surprised me the most. Alrighty. Okay, so now I'm going back to my hipster shop. I'm going to add items to the cart. Click place order. Nothing works. Like, can't do anything. I'm just stuck there. So that's interesting. Like, it doesn't give you an error message. It doesn't load any new page. You just get stuck on the page. So you're just like clicking the button, but nothing's going to happen. So that's a really interesting failure mode. Obviously, that's super bad for the customer experience if they're not even being told like why something's not working. There's no error messages. There's no handling of the error from the customer's perspective. They're just clicking and nothing's happening. So one other thing that we do is check in our monitoring. Is everything else working okay too? Because one of the things with chaos engineering as well is that you want to be able to identify what issues occur if I inject this failure. So for example, when the network engineering team throttled my traffic, it then meant that backups, clones, restores were all way slower, which meant that some of them actually failed. Some of them had to keep retrying and processing. That creates like more backlog. So there's a lot of issues that go on. And here you saw we actually got this 500 error. So I'll just rewind a little bit in case you missed that. So yeah, I did this black hole attack on the payments container. But I did get this 500 internal server error too. So everything totally broke. The whole entire demo app broke because I black holed just the payments container. So yeah, definitely not something that I expected. So I halt the attack and then I go and restart everything to get it to work again. That's a pretty interesting experiment. And now you can see that it's working because I stopped the experiment from running. Yeah. Alrighty. Okay, so now I'm going to do one more experiment. Black hole attack on a catalog. So this is just one container and it's the product catalog. We're going to do it for 60 seconds. So here for this experiment, what do you think is going to happen if I black hole the product catalog? So the ability to display like items. The whole site's going to go down. Good hypothesis. Let's check it out. So yeah, this really, depends on how the system was built for how it's going to handle me doing this attack. But I do the same thing, scroll through, I'll find the catalog container. Here we go. There's so many containers, much easier to just search. And I'm going to choose network, black hole. I don't have to change any of the other settings. But you can do that if you want more fine, granular experiments. Okay, so now we're going to start to run this. So I'll click around on the UI to see what does it look like so far. No, I was trying to click and couldn't really do anything. So yeah, I'm just sort of stuck here on this page. So that's it. I'm like, okay, I can't get anywhere. I'm just stuck on the home page. The home page loads, but nothing else loads. I can't go anywhere. I can't look at any of the product catalog items. I can't purchase anything. So I just have to halt the attack straight away. But that was interesting, different than I thought. I wasn't sure exactly what was going to happen. I thought maybe the product catalog images wouldn't show up and the text for the product catalog. But instead, it was really interesting because we saw that we actually do have the product catalog on the homepage. It does show up. You have the images, you have the text, you have how much everything costs, but you just can't use the website. It's unusable. So it's kind of just in a frozen state. Alrighty. Yes, exactly. There you go. Can't really do much. So now, next one. How do you communicate your results of your chaos engineering experiments? So you're going to identify a lot of interesting things that are usually quite difficult to explain, right? Because if you see a video of it, you can go, oh, that makes sense. But what I think is really important is to focus on metrics. Like, what experiments did you run? What were the results? And how did they improve your metrics? Did you reduce incidents? Did you make things faster? Did you improve like backup time, restore time, clone time? Did you create a better experience for your customers? I really recommend like writing up reports of all your experiments and sending those out to your entire engineering team and getting everyone at your company to understand why this is important and how it can help you learn how to create a better experience. Think about, was it expected? Was it detected? And was it mitigated? Fix the issues. Think about if you can automate it. You can automate your chaos engineering experiments. That's really good to do. Then share your results. And you can get started by doing validation and monitoring, reproducing incidents, exercise your runbooks or your playbooks, confirm disaster recovery works, automate your chaos tests. And also, we actually are running a conference called ChaosConf. Join us, come along and hear some great talks. We've got Dave Renson from Google, who created CRE, speaking as the opening keynote. And there's a special code, Insider, for 49 tickets. It's on September 26 in San Francisco. Thank you so much. And these slides are on Speaker Deck.